Hi Year 12. Today we're going to have a look at some annuities problems. So we're going to do this through an example. The reason we're doing this is because occasionally when you are working out final values of an annuity, we actually want to know where we're going to be at other points in the annuity. So we don't just want to know the final value. We want to know, let's say, halfway through the time periods, exactly how much interest we've paid, how much we still have to pay back on a loan, or how much we've gained on a superannuation account. So we're going to be using tables to set out exactly what our financial position will be at each point in time. So we're going to look at this example. So here we are talking about a home loan. So Josh takes out a home loan of $350,000 to buy a house. The bank offers 4.2% per annum in interest, compounding monthly over 25 years. Josh will pay off the loan in monthly installments of $1,867. So, first question that we're going to answer, what is the monthly interest rate? Now we've done this stuff before, so this will just be a revision. If the interest rate is 4.2% per year, then that means per month we need to divide by 12. And what we end up with when we do 4.2 divided by 12 is 0.35% per month. Or, as a decimal, 0.0035. So we're going to use that for the next part of our question. Okay, next we're going to use a table to find the amount owing after 12 months. So in this table, we're going to have a column showing which month it is. We're starting with 0 so that we have our original balance in this table. Payment just refers to the $1,867 that's being paid off the loan each month. Interest, we're going to calculate just the interest earned for that month. The reduction, I'm going to talk about when we get there, but that's how much is actually being taken off the loan once we calculate the interest that's been paid. And then the balance will be the final amount at the end of each month. And then after 12 months, we'll have our final balance for the year. So we always start with a 0 row in these tables. So before we've actually started the month, we haven't paid anything, no interest earned, nothing has come off the loan, and we're just starting with our $350,000 that's been borrowed. So we add that row in because now we're going to use that to work out the row for month number 1. So at month number 1, the payment is $1,867. That's actually going to be the same for the whole 12 months. So we can fill it in exactly the same down that column. The interest, we just worked out that it's 0.35% per month. So the interest for month 1 will be 0.0035 times by the balance. So in your calculator, you're doing 0.0035 times by $350,000. And that works out to be $1,225 in interest just for that month. Now, the reduction, what this means is Josh is paying $1,867. $1,225 of that money is going to go to paying off the interest. So the rest is going to be paying off the actual loan. So what that means is we need to do 1867, take away the amount that's going towards interest, because the rest is what's actually being reduced from the balance of the loan. So when we minus those two numbers, we end up with $642 that's being taken off the actual loan. So what we do now is we take that off the loan. So we're going to do $350,000 take away the $642 that's coming off the loan for that month. And we end up with $349,358. Then we go back, we start that all again. So for the second month, the interest is going to be 0.35% of what our balance now is. So we do 0.0035 times by 349,358. And we end up with $1,222. So you can see, because we don't owe quite as much now, we're not being charged as much interest this month, because the interest is calculated on how much is left to pay. When we pay the $1,867, $1,222 of that goes towards interest. So what's left is what we get when we subtract those two numbers, which is $644 being paid off the balance. So now, balance, take away the amount that we're paying off, leaves us with $348,714. I'll fill out one more row so that you get the idea. The interest for month number 3 is the balance times by 0.35%, or 0.0035. So the interest for month 3 is $1,220, and it should be getting less as we pay the loan off. When we do $1,867, take away that amount that's going towards interest, we're left with $647 being paid off the loan. And then to work out our balance, we're going to do what our balance was at the end of 2 months, take away what we've just paid off the principal. And we end up with $348,067. So I'm not going to go through the whole of that table. What you can do now is pause this and fill out the rest of the table up to 12 months. And then you can check in the notes to see that you got the same final balance as I did, and the final balance should turn out to be $342,145 at the end of 12 months. But now this table is particularly useful because for each month we can see how much interest we're paying, how much we're actually taking off the loan, and what our balance is at the end of each loan. That's why these tables are useful. They break down an annuity into separate time periods. Okay, a couple more questions. Part C, how much does Josh pay back over the 12 months? So all we need to do here is we look at how much he's paid. He's paying $1,867 a month for 12 months. So if we multiply his monthly repayment by 12, then we get the total he's paid in the year, which is $22,404. Part D, what was the total interest charge for the year? There's 2 ways to do this. The long way is to go back and add up all 12 different amounts of interest for the year to get your total. The short way is to say that we started with $350,000. We ended up with $342,145. So the amount that was actually reduced in the balance of the loan was $7,855. So that's what was actually paid off the principal. But we just found out in Part C that Josh paid $22,404. So that was principal and interest. If we take away what he paid off the actual principal amount, whatever's left must be interest, which is $14,549. But if that's not really making sense, feel free to just go back to the interest column and plus those 12 numbers together. You'll get the same thing. Now, one more thing that I will note is that that was a table when we're looking at a loan and we're paying off the loan, so our balance is getting smaller. If we're looking at superannuation, then we're actually adding on payments and our interest is being added on as well. So the balance should be getting bigger. So what if the scenario is superannuation rather than a loan? What I'm going to do here is really quickly show you exactly the same numbers, so $350,000, but for a superannuation account. So this time, instead of paying off $1,867 a month from a loan, he's adding that money on top of the money that he started with. So he's saving up this money and he's adding more and more on each month. So what happens in that case is our first amount of interest is going to look exactly the same because it's just 0.35% of the original. But now, instead of a reduction of the loan, what we're doing is we're adding money on. So this time we don't minus to get this column, we plus, because he's paying $1,867 plus he's earning $1,225 in interest. So those two added together make $3,092. And then we add that onto the loan to get the new balance. Sorry, we add that onto the balance to get the new balance for the month. So for this table, we're actually plussing the money together each time. So this column is different. We're plussing them together. These are the same. The payment is exactly the same for each month, and the interest is just 0.0035 times the balance at the end of the previous month. And then here we're not subtracting, we're adding on to get more of a balance because he's saving more and more money.